for the HL students, they will be learning more stuff about the period 3 elements, okay? So they'll need to know about the oxides. So they have to know the reactions between the elements plus oxygen to produce the oxides. So they have to memorize the equations. We have already given the equations in the notes, so the students can just memorize them. And they need to know the trend of properties of oxide, okay? Also across period 3, so stuff like electrical conductivity, pH in solution, acid-base nature, whether it will be solid, liquid or gas, so all are in the table that your student can just refer to and memorize. You also need to, so from this oxide you need to see whether, well, the students need to know the reactions with water or with acids or with base, okay, if applicable. So again, all the reactions are given in the notes, okay. Another thing that the students need to know about will be the trends of this is oxide. You also need to know about the chlorides, okay. Same, electrical conductivity, pH in solution, the nature, whether it's ionic, whether it's acidic, the types of bonding, ionic, is it covalent, simple covalent, and so on. Okay, and this one, the reaction of this with water. Okay, what products they will give. This one also need to be memorized. In periodicity, the students are also going to be learning about the first row D block elements, okay? But mainly we are going to focus on the transition elements in the first row of the D block in the periodic table. This should be a fairly new topic to them, so I think most students will need to pay more attention to this part, and you need to be able to explain it more clearly and simply, okay? So first you will explain what is transition, what are transition elements, okay, what is the definitions, and why are they considered as a transition element, as transition elements. So you need to emphasize that as a transition elements, we are talking about the oxidation state of the element, or rather about the electronic configuration of the element in their common oxidation state. Involves a partially filled 3D subshell. Okay. So always emphasis is about the oxidation state in electronic configuration of the element in their common oxidation state. It's not about the element itself, but after it reacted with something, after there is a change in the oxidation state from 0, then they have a partially filled 3D subshell. Then you can talk about the 4 characteristics of transition elements, which are variable oxidation state, okay, complex formation, colored compounds, and catalytic property. Meaning that the transition elements will be exhibiting these four characteristics, okay? So you need to be able to explain why there is a variable oxidation state, why it will form complex, and then in the complex formation you need to be talking about ligand ligands. Okay, you need to be talking about coordination number, how to find oxidation state of element in a complex. So these are just some of the subtopics that you need to be explaining to them. And then colored compounds, it used to be the most asked question in this topic. How, rather why the first row D block elements, why transition elements form colored compounds. So you need to be able to teach your students how to do that. Okay, like some important point will include partially filled 3D subshell. Okay, and then ligand causing DD splitting. Okay, and then electron transition from lower level to higher level. Absorption of energy corresponding to energy to visible light. Okay, and then the last part will be about complementary color will be observed. Okay, so usually these are the 5 points. They won't give you 5 marks for this. They will see if once you have like 3 points, then they'll give you 3 points. Yeah. Then the last one will be about catalytic properties. So you need to be explaining about homogeneous and heterogeneous. Catalysis. And what attributes or what property of transition elements allow them to be a homogeneous catalyst or a heterogeneous catalyst, and give some examples for homogeneous catalysis and heterogeneous catalysis. That's all for chapter 3.